So this question is basically about the differential equation, solving differential equation, and the um, set question is that you have to find out the general solution of this differential equation uh, in y equals to fx form. Means this has to be explicit form. So the question that here they have also given further data is then when x is 1, it has been given that y is -1. So when x is 1, y has been given as -1. Now, first impression is that when you look at this problem, that is what strategy should I use? They haven't given any of the method that we have learned in the class. So when you look at the question is that if you make dy by dx the subject, you can clearly write down this as y squared plus 3xy plus 3x squared over x squared, which is going to be y squared over x squared plus 3x over x 3x over x squared y plus 3x squared over x squared, which is basically nothing but like you can see that this is like y over x the whole squared plus 3 times y over x and plus 3. So you can clearly see that I can write down basically the function that has been given as a function of y over x. Also, you can see that each term has the same degree. Each term has a degree 2, combined degrees 2. Like here you see degrees 2, here you see degrees 2, 2 and 2. So that is like a way to identify whether it's homogeneous or not. So this question is actually a homogeneous question. So what you're going to do is our next step is to actually take the standard substitution that we take for homogeneous questions. So y equals to, you take vx, take y equals to vx, and obviously because you're taking y as vx, in place of dy by dx, if you apply product rule here, you get v times 1 plus x times dv by dx. So which is v plus x dv by dx. And so what you get is basically dy by dx, that is you're going to replace with this. So v plus x dv by dx equals to, now in place of y, you're going to put v squared x squared. So I mean v squared x squared because it's y squared plus 3x times y is nothing but vx plus 3x squared over x squared. So what you get is basically you get v squared plus 3v plus 3, and if you take x squared common from here and x squared common from here, we can strike it out. So this and this get cancelled. So now if you move this v to the left hand side, v from here to right hand side, basically what you get is x dv by dx equals to v squared plus 3v plus 3 minus v. This 3v minus v will simplify to 2v plus 3 and x dv by dx. Now after this step, what we got is you have to separate the variables. So dv upon v square plus 2v plus 3 equals to dx upon x. So the major step is here, the integration of this part. So here, as we see that integral of this part will be using the arctan formula, because if I make the perfect square of this form, it'll be v plus 1 the whole square and plus 2 and equals to integral of, I mean, dx upon x. So now if I integrate both sides in this case, what we get is the actual value or the integral. So this form, this particular integral is actually tan inverse of or arctan v plus 1 over 2 and equals to ln x plus c. And so now the next step is to find out the missing constant. So what I'm going to do is I'm just going to erase all of these stuff. So I'll just clear out all this drawing. So what we have got is ln tan inverse of, so tan inverse of b plus 1 over root 2. Actually, that integral was not correct. B plus 1 upon root 2, 1 over root 2 equals to, you get is ln x. So after you get the integral, which is what we get is, after making it to the perfect squared form, we get is 1 over b plus 1 the whole squared, which is b plus 1 the whole squared here, and plus 2. So that was one of the integral to the left hand side, and the right hand side was dx upon x. So what you get is, this integral is of the format integral of 1 over a squared plus x squared dx, so which is 1 over a tan inverse x over a. And so here what you're going to do is 1 over root 2, because a is root 2, tan inverse of b plus 1 over root 2 equals to ln x plus c. And then you're going to substitute the values that they have given to us in the, like, to get the constant, and you can get the function. You can substitute back, in place of v, you can substitute back y over x, make y the subject. So what you do is first bring in root to the side. I'm not finding the constant, assume that it is not given. So tan inverse of v plus 1 over root 2 is basically gonna be root 2 times ln x plus c, and now v plus 1 over root 2 is gonna be tan of root 2 ln x plus c, and then you once again you cross multiply with root 2. So v plus 1 will be, so v is gonna be tan root 2 tan root 2 ln x plus c and minus 1. And in place of v, now you can plug in y over x, because, and then you can cross multiply x. So the final answer will be y equals to this as, and obviously you need to find the missing constant by substituting the given x and y coordinates. So this is the general solution of such kind of questions.